Hi everybody, this week we're going to be working on lines and quadrilaterals. And I know that last week we worked on some lines and angles, and so this is just going to take us a little bit further. So lines and quadrilaterals, lines we've talked about, there's different degrees of lines, we can measure lines, they go on forever. Now we're going to just talk about a few more, and also quadrilaterals. And quadrilaterals are just the shapes that are closed with straight lines, and they have four sides. So all of these pictured here are four-sided quadrilaterals. We can tell 1, 2, 3, 4. We've got 1, 2, 3, 4. So all of these are quadrilaterals. All right, so let's move on. Okay, so in today's lesson right here, it's asking us that to do something. So pay attention, then I want you to try it and turn off the your computer or pause it so that you can see if you did this correctly. All right. So it says right here, the number line below is an example of a line, and we talked about it last week. A line goes on forever in a straight path in two directions. Draw the following pairs of lines. Two lines that will never cross, two lines that cross at one point, two lines that cross at 2 points. If you cannot draw the lines, tell why. So I want you to stop, and I'm going to read it one more time, and I want you to, of course, you should have your pencil and paper with you, and I want you to try this out. All right, so it says, draw the following pairs of lines. So it says two lines that never cross, two lines that cross at 1 point, and two lines that cross at 2 points. If you cannot draw the lines, tell why. So again, remember, a line is something straight, just like this one, that goes on forever. And here's the hint. It says, be precise. Think of the use of a math line, which you already know. Show your work in the space below. So go ahead and try this out in your book, and then come back and see if we have the same answer. Okay, if you came back, that means you tried it, or you're just wanting to see it, and that's fine too. All right, so it says, the first one says two lines that never cross. So two lines that never cross. There's one of my lines, and it's straight. And then here's another line. And these lines, since they go on forever, will never cross. They will never cross. So these are called parallel lines. Parallel lines, they never cross. Then the next thing it asked me to do was two lines that cross two lines that cross at 2 points. Okay, that one. And then the other one was, two lines that cross at 1 point. So let's try two lines that cross at 1 point. So we're going to draw them. There's my line. And they have to cross at some point. So I'm just going to draw this right here. And so we have a point that they crossed right there. And these are called intersecting lines. This is intersecting lines, lines that cross. Now the third thing I read was that it said to draw a line that can cross at 2 different points. So if I draw a straight line, how can I get another straight line to cross at 2 points? It can't. You can't bend the line, and it's just one line. So this last thing that it says, two lines that cross at 2 points, cannot be done because a true line is straight and it never crosses. So it would always keep on going in the same direction, and you can't bend one of these lines. So that's why that can't happen. All right, so here's another place to prove it. Terry said that the lines shown intersect at 3 points. Is Terry correct? Well, sure, they are. We see a little mark here. We see these are where they would intersect, but then that curved line, this line is not a true line because a true line is straight. So yes, these do have intersecting on that bottom line, but the curvy line is not a true line. So sorry, Terry, but that's not correct. All right, so a line, like we talked about, is a straight path that goes on and on in the opposite direction. A pair of lines can be described as parallel, perpendicular, and intersecting. So these are the three types of lines we're going to talk about: parallel, perpendicular, and intersecting. So she says right here, a railroad tracks in the picture are parallel lines because they never meet. So these train tracks right here that I'm drawing this blue line are, this train tracks, these two are never going to meet. If they met with something else, I'm sure the plane would derail and crash. So they're parallel lines that are never going to intersect. All right, and then the railroad ties are perpendicular to the railroad tracks because they intersect at right angles. So these are the railroad ties, which she's describing. These are the railroad ties, and they go across like this, and they're causing a right angle that we talked about before. So right here, this is, if I was measuring this, this would be a right angle. Remember I told you that the little square means that it's a right angle. And so those lines, they do intersect, but they're perpendicular because they form a right angle. So here's the pairs of lines we're talking about. Parallel lines. Okay, parallel lines, like when you're driving on the freeway and the lines keep on going and they never intersect. Those are parallel lines. Parallel lines never intersect, they'll go on forever. Intersecting lines. Intersecting lines cross, and they can cross anywhere. So an intersecting line is anywhere, a line that crosses. We have, that's what we call intersections. Intersections because the two roads intersect, they cross. And then we have perpendicular lines, and perpendicular lines, like the right, like with angles, right when you see the square, that's the dead giveaway to let you know that this right here forms a right angle, forms a 90-degree right angle, and so we call these intersecting lines perpendicular. They have a 90-degree angle. All right. Okay, so here we are. We're going to enlarge this a little bit so we can see this a little bit better. Whoops. All right. So this first question we're going to go over just to go over the lines, but it says, what geometric term could you use to describe the top and bottom edges of your book? So if you have a book, and you have a book, and here's, I'm going to just draw, oops, let me just get this. I'm going to draw a book right here. And this is the top edge, and this is the bottom edge. Well, those describe parallel lines because they are never going to meet. So these are the parallel lines. These lines will never meet. So that is parallel lines if we're talking about lines. So the top of a TV, the top of your book, anything that are not going to meet are parallel lines. Okay, and it says here, what pair of lines look like the blades open in a pair of scissors? Well, if we have scissors, and we know that scissors go like this, and they have a handle here, and then they go like this, and they have another handle here. Well, we see an angle right there, and they intersect right now, so that's an intersecting. That would be intersecting if we were talking about, well, I'm not doing that very well, but intersecting lines like we talked about on the previous page. Now, if the scissors were wide open, if we had the scissors and they were wide open and there was a blade here and then a blade here and then here's the handle and here's the handle, this would be perpendicular because the blade would be so open that it would cause a 90-degree angle. And so that would be perpendicular. So scissors, if you opened them up all the way, you could create a perpendicular lines. All right, let me see if I can enlarge this a little bit more. Okay, so right here it says, name the 4 points. Name the 4 points. And remember, points are just those dots on something. So here's a point, here's a point, here's a point, and here's a point. And so if we're going to name those points, we would just call them W, X, Y, and Z, and those are the points. All right, the next question says, name the 4 lines. And we kind of did this when we're naming angles, but this time when you write your lines, you're going to create these little lines so that you could show that those are lines. And I'm going to look at this one right here, so this line right here. So this would be WX, line WX. All right, and I'm going to, there's another line. So if I look at this line here, that is a W. I'm sorry, that should be an X. WY, that would be that line. And then if I look at this line right here, That would, again, write it with the little arrows both sides. And that would be an XZ line. And then if I look over here, that would be line Y, Z. So we'd have all 4 lines written. All right, and then it says name 2 pairs of parallel lines. Well, we have 2 pairs of parallel lines, and it would be, let me get a different color. It would be this right here and this way. They're parallel. They're never going to meet. So the parallel lines would be W, X, and of course we've got to write the line symbol, and Y, Z. Those are the 2 parallel lines. And then we've got another set of parallel lines right here and right here. And we would name those parallel lines, again, we have WY, are parallel to XZ. So XZ. So those would be the parallel lines. All right, and then it says name 2 pairs of perpendicular lines. Oh my goodness. So perpendicular, let's see, get a different color. I'll get the screen. So remember, perpendicular lines make right angles. So again, since it makes a square in the middle, we have quite a few. So we have WX. So WX right here. Let me erase some of these lines. Let me erase these lines. Okay, so we'd have WX. So there's a right angle here, and then there's a right angle here. So we'd have WX, and since we've got 2 in there, we'd again do WX, and you would write them because you want whoever you're answering this question to know that there's 2. So there's here and here. And then we look again, and I've got a perpendicular line here and a perpendicular line there. So I would say WY, Y, because I've got it right here. And then I would have right here, which is XZ, so another line. Okay, and so this would be WX. So I've got let's see, I've got WX and XW, okay, there, so YZ. And so these would be the ways of marking those perpendicular lines, okay? All right. Now here we've got, it says geometric terms describe what is shown. So right here, I'm hoping you'd pick, these are parallel lines, all right, because they're never going to cross. And right here, this is perpendicular lines because it's got the square right there and it makes a right angle. This, I hope you know, would be a point. Good, a point. And then over here, we'd have perpendicular lines because, again, it makes a right angle right there. These would be parallel lines. These would be intersecting lines. And then here, I would ask you if you had your book to draw it. So again, a perpendicular line would be a line like this and then have the little square. And of course, you need a straight edge because it's a 90-degree angle. Intersecting lines would be, any kind of intersecting like this, but make sure you put the arrows. Okay, and then parallel lines would just be those straight lines that are never going to meet. Okay, so it is a lot of a memorization in geometry, but once you get them, you'll be fine. All right, and it says here, draw 3 different 4-sided shapes. Okay, 3 different 4-sided shapes that have opposite sides parallel. Opposite sides parallel. So remember, these are the parallel lines. Okay, and you need to draw shapes for 3 shapes with 4 sides that have parallel lines. So stop it right now and see if you can do this, okay? So stop it right now. And then I'm just going to read the little hint. It says you can generalize, use what you know about parallel lines and angles to draw quadrilaterals. Show your work on the space below. So go ahead and get a piece of paper and draw and see if we can have some that match up. So do that now. Okay, if you're back, that means you tried it. So one quadrilateral that has parallel lines is, I could draw a square. 4 sides, they're all straight. And these right here would be the parallel lines, okay? Those would be the parallel lines. All right, so I could also draw a trapezoid. And you might say, oh, but those sides aren't straight. You're right, but these are the pair of parallel lines. These will never meet. If we tried the other side, these would meet eventually. These would meet because we know that lines go forever and those would end up forming that. So the trapezoid and the square, and then I could draw something else. I could also draw a rectangle. And again, the two parallel lines, I could pick the parallel lines. Let me just, could be, I could see these are the parallel lines. Or just like I could over there, I could do these as my parallel lines. And in fact, these are parallel lines too in the square. So those would work. They would just have to be, have the parallel lines, the lines that are never going to meet. All right? So here are different kinds of quadrilaterals. So quadrilaterals can be classified by their angles or the line segments that make their sides. Which of the quadrilaterals shown have only one pair of parallel sides? Which have two pairs of parallel sides? So this one has parallel sides. A parallelogram has two pairs because it's got this. These lines would never meet, and these lines would never meet. They would just keep on going. So they have two pairs of parallel sides. A rectangle has 4 right angles, and it also is a parallelogram. Parallelogram has these two sides would never meet, and these two sides would never meet. So those are parallelograms. And then a square has 4 right angles, and all sides are the same length. It is a parallelogram, a rectangle, and a rhombus. So these have parallel lines. These are parallel, and then these are a set of congruent parallel lines as well. All right, so remember, congruent is that there's the same size. I think we talked about that when we were talking about angles. All right, let me move up. Now, a rhombus is not a parallelogram, but it is a quadrilateral, because a rhombus is a quadrilateral, has opposite sides that are parallel and has all the sides, the lengths, same length. So these would, that's also, it has parallel lines right here, okay, and parallel lines right here. And then here, a trapezoid is a quadrilateral that only has one pair of parallel lines. So this rhombus, or what we call diamond, it is also a parallelogram because they're never going to meet. But this trapezoid, like we talked on the previous page, these are your parallel lines, but eventually, since lines go forever, these would meet. All right, so parallelogram, 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 parallelogram. And here, this is a rhombus, a quadrilateral, opposite sides, and a parallel, and all sides are the same length. It is a parallelogram. And this one is not a parallelogram. It is a quadrilateral, but not a parallelogram. All right. Okay, and then here's just another look at all of these shapes. So here we have a quadrilateral. We have a quadrilateral because it has 4 sides. 1, 2, 3, 4. But it doesn't. It's not a parallelogram. These lines would meet. Here's a rectangle because it's got 4 sides. And it has right angles. So that's what makes a rectangle. It's got the right angles. And it has opposite sides of parallel. So again, these would be parallel. These would be parallel. So it's also a parallelogram. Okay, a parallelogram has opposite sides are parallel. All right, and a square, again, another quadrilateral. It's got 2 pairs of parallelograms, so it's also a parallelogram. And then the rhombus, opposite sides are parallel and all sides are the same length. Then a trapezoid that only has 1 pair of parallel lines. All right. So you're going to be asked to identify these specific, what makes these up. So remember, this one has 4 sides, so it's a quadrilateral. It's a quadrilateral, and it has 2 sets of parallel lines that are never going to meet. So all of these shapes are quadrilaterals. Some have 2 pairs of parallel lines, and some just have 1 pair of parallel lines, the congruent side, okay? All right, and let me just make this go up. Okay, so then here, when we identify these, you're going to be able to write what parallel versus perpendicular. So here we see the symbol, and this means parallel. This means perpendicular because it's got a right angle, perpendicular, and this means parallel. So we're looking at EB, and so I'm going to just line EB, and line EB is, line EB is this one right here. So we're looking for what line is parallel, going in the same direction, parallel to EB. Well, this one right here is parallel. All right, so there we could write, so EB is parallel to KH. So we would write KH right here. All right, now we're going to do the perpendicular. So remember, perpendicular makes a 90-degree angle. So I'm right here. And so I've got TB. And so here's line TB. And it creates a perpendicular or right angle with ZQ. So right here, I'm just going to put ZQ. Okay, and you will see this slide on your assignment this week. So look at this if you need it. These videos are supposed to help, not confuse. I wish I was there teaching with you, but so let's just go over really quick. Lines that never meet are called parallel lines. Lines that cross, pretend these are neater. That's an intersecting line. Lines that intersect and make a right angle are called perpendicular. And then we talked about that quadrilaterals have 4 sides, and some of these quadrilaterals there's a pair of parallel lines, and this one has 2 sets of parallel lines, so that's a parallelogram. And then also you might have, like if you have this only has a trapezoid, only has 1 pair of congruent or lines that match, so it's a parallelogram. I mean, it's not a parallelogram, it's got 1 pair of parallel lines, okay? Parallelogram has 4 sides that have parallel lines, so this one right here. This one just has 1 pair of parallel lines. If we tried to draw these any further, this would be forming a triangle. So I hope that helps. I know it's a lot to learn. Geometry is a lot of memorization, but just remember these things and come back to this video if you need to. Have a great day, you guys. I miss